Yeah, in the last class, we have taken the same type of problem. You can read here PV raised to 1.5. So earlier class we have taken PV raised to n, where n value we have changed 1.5, 1 and 0. So same thing for the given gases, this n value or the gamma value is going to change. So similarly, one more problem which covers both work and heat as well as first law of thermodynamics. So in that case, I'm going to read this problem and I will explain once again how the work done we are finding, like earlier class, and also how we are finding the heat exchange or the work done using first law of thermodynamics. So I'll read the sentence first. 4 tenths kilogram means 4 by 10 kilogram. So 4 by 10 if you take, it will be 0.4 kilogram of a certain gas is contained within a piston cylinder arrangement. So again a piston cylinder arrangement is taken. The gas undergoes a process for which the pressure volume relationship is PV raised to 1.5 is constant. So based on these conditions, I can directly connect this problem with a process, okay, a polytropic process or type of a process where PV raised to n or PV raised to 1.5 is constant. Next, they have given the initial pressure is 3 bar like the earlier case. The initial volume is also 0.1 meter cube, and the final volume is 0.2 meter cube. So there is a change in volume means there is work done at 3 bar pressure. The change in specific internal energy. Now you see the wordings. These wordings will come under first law of thermodynamics, where change in specific internal energy. Specific means per kg. Now the kg given value is not 1 kg here. This is how much? It is 4 by 10. 4 tenths of the kilogram. That value you have to consider for the problem solving as a mass. Next you can read, with this specific internal energy change of the gas in process, that is U2 minus U1 is per kg. Because I told you specific internal energy is given, it is per kg. We need to find out for 4 by 10. That is for 0.4 kg we need to find out. So before that, I'll just find out the difference. Means they have given in the problem, difference is U2 minus U1 is minus 55 kilojoules per kg. So much of internal energy is already contained in the system. There are no significant changes. Read carefully. There are no significant changes in kinetic or potential energy. So these wordings are very important to solve in the future for first law of thermodynamics, where internal energy, kinetic energy and potential energy, all these things are going to combine to find out the net energy change in the system. So question is, determine the net heat transfer for the process in kilojoules. So as earlier case I told you, we found out the work done. So work done we found out around plus 17.6, that is work done by the system. When work is done by the system, so whether the heat is transferred, okay, to the gas or by the gas, or whether focusing on the piston, whether the piston is taking the heat or releasing the heat. So that we have to decide by sign of the heat transfer. This we need to find out in this problem. So problem number A, that is 2.1, already part is solved, where we found out work done is plus 17.6 kilojoules. And again, when mass is changed, we got it around 22 point something. So now today also I'll read once again till work done problem. So these things we have taken earlier. Okay. Now see the internal energy change. U2 minus U1 for 1 kg, they have given minus 55. So considering this is the process, PV raised to 1.5, volume is increased